When doing any scientific investigation, it is important to take into consideration a few simple ideas. There are two main types of investigations you will be undertaking. A first-hand investigation is one that you do yourself. An example of this is the experiments you do in class. A second-hand investigation involves doing research based on other people's first-hand investigations, taking other people's information and using it to find out things. An example of this is working out what the gravity is like on other planets. Our first question is the investigation valid? For a first-hand investigation, is it a fair test? Does the method or the design of your experiment test your hypothesis? Have you identified the variables, and do you have adequate controls? For a second-hand investigation, who wrote the information you are looking at? Is the person an expert? Is the information recent information more than 10 years old may no longer be accurate? Do the findings answer the question asked by your hypothesis? Was some of the information from primary research? Next is reliability. This is an indication of the quality of your research. For primary investigation, have you repeated your test a number of times? At least 3 trials is good, however, your results must be consistent. If they have wildly different results, then there may be problems with your experiment. For a second-hand investigation, the information that you have received from your valid or reputable sources must be the same. If you get different information from different sources, then at least one of them must be wrong. Also, when you look at these second-hand sources, have the experiments they were based on been repeated by other people? Finally is accuracy. This is mainly related to first-hand investigations. It relates to how precise the measurements you have taken are. For example, if your experiment requires 5 milliliters of one solution to be mixed with 5 milliliters of a different solution, you would probably measure that with something like a pipette, which is designed to accurately measure the volume of a liquid. You probably would not use a large beaker, as it doesn't have accurate graduations or markings. It can only give you an estimation of the amount of liquid. In mixing the liquids you may get results, but they may not be very accurate, and someone repeating the experiment with more accurate equipment may get better results. A famous example of accuracy is the Michelson-Morley experiment. The aim of their experiment was to determine properties of a substance called ether. Ether was thought to be the medium that light moved through. Ether was the Greek god of light. At this point of scientific history, it was though that all waves needed a medium to travel through. All waves previously discovered needed a medium, so it seemed obvious that light needed one as well. The ether would fill all of space, but be barely detectable. They passed light through an apparatus that made the light split, then hit mirrors, before being recombined. The ether being a medium, would slightly influence the speed of the light waves and create an interference pattern. Their experiments showed no detectable change in the light patterns. They thought that all they needed to do was make their measurements more accurate, which they did. However, there was no detectable ether, and a young man called Albert later held that no matter how accurate their results, they would never find the ether.